Hello, everyone. So, today we all have assembled here to discuss important topics of your chapter Matter in Our Surroundings of your grade 9th. Hi, Drishti. Good evening. Hello, Krishna. Hi, Raghav. So, before moving on to the chapter directly, let's first discuss what is the marks distribution of your whole syllabus. So, as it's already shown in the table, that your chemistry, which is your matter, its nature and behavior, which consists of your 4 units, is of 23 marks weightage, and your organizational living world, which is related to your biology, is carrying 20 marks. Similarly, motion, work, and force, which is your physics part, it carries 27 marks, and your R environment, again related to your biology, is having 6 marks, whereas food and food production is carrying 4 marks. So this is your whole weightage of science, which total carries 80 marks, and the rest 20 marks are decided by your school. So this was about your marks distribution, how the marks have been distributed among the different branches of your science within your syllabus. Moving on to the chapter that is your matter and matter in our surroundings. So let's quickly have a recap of what all is included in the chapter. So first of all, we all have studied the matter, and we all know anything which occupies space and has mass is known as matter. We have also studied about the characteristics of the particles of matter, which includes that particles have spaces between them. Particles are continuously moving, that means they have a continuous motion. Then we have also studied about particles attract each other and particles are very small in size. So we have studied about all of the characteristics of them. After that, on the basis of the physical properties, we have studied about the different states of matter, which includes your solid state, liquid state, gaseous state, plasma, and Bose-Einstein condensate. For your 3 states of matter, that are solid, liquid, and gases, we have studied about the different properties like your shape, volume, density, rigidity, diffusion, kinetic energy, compressibility, intermolecular forces, and intermolecular spaces. After that, there are 2 more states of matter that are plasma and Bose-Einstein condensate. Let's quickly have a look on them. So we all know that plasma, which is a mixture of free electrons and ions, and it's the most common state of matter found in the universe. High temperature and low pressure are required for the formation of such ions and availability of free electrons. Also, they are found in sun and the stars. This was about your plasma, which is the 4th state of matter. Moving on to the 5th state of matter, that is the Bose-Einstein condensate. So it consists of supercooled particles and is generally formed when the gas of extremely low density is cooled to extremely low pressures. So these are the characteristics of your plasma and Bose-Einstein condensate. Moving on to the next thing, that is your classification of matter on the basis of your chemical properties. We have also discussed that on the basis of your chemical properties, the matter is classified into pure substances and mixture. We generally know that this is part of your second chapter, so quickly giving you a brief overview of this right now. So the pure substances are again classified into 2 categories, compounds and elements are further categorized into metals, non-metals, and metalloids. Similarly, your compounds are again classified into organic and inorganic. Moving on to your mixtures, mixtures are of 2 types, homogeneous mixtures and heterogeneous mixtures. This classification is basically done on the basis of the uniformity of composition. If the whole mixture is having uniform composition, then we call it as homogeneous mixture. If the composition is non-uniform throughout, then we call it as heterogeneous mixture. Moving on to the states of matter back, we all know that these states of matter, that is your solids, liquids, and gases, they are interconvertible and can be changed into each other. So, and that is basically due to the 2 major effects, that is by the effect of temperature and by the effect of pressure. Shashank, Pravin will discuss about semi-metals in your next chapter. Metalloids also will be coming into your next chapter. So let's focus right now on your matter in our surroundings, the changes of different states of matter. So moving on to the different processes which are involved are involved in the interconversion of your states of matter are your freezing, deposition, sublimation, evaporation, melting, boiling, or vaporization, condensation, or liquefaction. So these are your general states of matter. As we all know that melting is the change of state from solid to your liquid. Similarly, evaporation or boiling, we generally say the state of change of your liquid to your gases. Moving on to your sublimation, that is basically the change of state from your solids to directly into the gaseous state, and the opposite is known as your deposition. Condensation is the change of state of your vapors to your liquid state. So these are all your processes which are involved in the change of your state. In details, we all know that we have to study about your evaporation and also what are the different factors which are affecting evaporation, like we have humidity, wind speed, temperature, and surface area. We all know that humidity is inverse, your evaporation is inversely proportional to humidity, which means if the humidity, that means the amount of moisture present in the atmosphere is more, then definitely the rate of evaporation is less. Moving on to your wind speed, we all know that it is your evaporation is directly proportional to wind speed. If the speed of the wind is very high, then definitely the rate of evaporation would be more. Moving on to your temperature, we all know evaporation is directly proportional to temperature. More the heat provided, more will be the rate of evaporation. And the next one is your surface area. We all know if the amount of surface area available for this evaporating substance is more, then evaporation is taking place is more. So these are your factors which are affecting evaporation. Also, we have to study about the cooling effects of your evaporation, which basically includes all your reasoning part, which includes why the water kept in your earthen pots becomes cool during summer, why we should wear cotton clothes during summers, and all such kinds of questions. So that was about the topics which are covered in this chapter. Moving on to the types of questions which can be asked in your exams. So there are basically two types of questions which can be asked from this chapter, which are your theory-based questions and also there is practical-based question. So your theory-based question involves the topics from which these are your topics from which your theory-based questions might be asked. For example, it's matter. You can be asked what is matter, the definition of matter, and how it is classified, the classification. Moving on to the different states of matter, like your solids, liquids, and gases, you can be asked about to differentiate between each one of them on the basis of their characteristics, your compressibility, shape, density, and many other, as we have discussed in the previous slide. Moving on to the next is the change of state. You can be asked about the definition of these processes: melting, freezing, evaporation, condensation, sublimation. So all these processes can be asked in your exams. Also, you can be asked about your Bose-Einstein condensate and your plasma, which are the two more important states of your matter. You'll be asked to write down the characteristics of them. So these are your general topics from which question can be asked in your exams. Moving on to your practical based questions. So in your syllabus, there is a practical, which is determination of melting point of ice and your boiling point of water. This is your practical, which is included according to your CBSE syllabus in your curriculum. So you have to go through this practical and you can be asked questions about that. Effect of change of pressure. See, if we apply a pressure on any substance, then the particles of that substance come closer to each other. As a result, the change of state takes place. For example, if I'm applying pressure on a gas, then the particles of the gas will come closer to each other. And as a result, what will happen? There would be increase in the intermolecular forces of attraction. As a result, they will come closer. Since the forces of attraction increase and the space between them decrease, there would be change of state from gaseous to your liquid state. Okay, Raghav, see, if wind speed is fast, then what will happen? It will take away the moisture from one place to another place. As a result of which, what will happen? The atmosphere, the region will be empty of the moisture. Then more amount of moisture will start, more amount of water will start getting converted into your vapors. So that is generally evaporation. So this is how your wind helps in fast evaporation. Moving on to some of the questions, let's discuss few important questions from this chapter. So the first one is latent heat of vaporization and latent heat of fusion. So you have to define these two. We all know what is latent heat. Latent heat is generally known as your hidden heat. And we all know when we continuously heat a substance, for example, if I'm continuously heating ice, then what will happen? First of all, the temperature will increase. But after a certain point of time, the temperature will not increase. The reason of that is The temperature, I mean, the heat is being consumed is in breaking down the forces between the particles of your solid. And that heat will break down the forces, and then that there would be change in state. The solid ice will get converted into your liquid water. And that heat consumed is your hidden heat because that is not being significant for the change in temperature. That heat is used in breaking the bonds between the particles. So that heat is known as your latent heat. We all know vaporization is a process of conversion of your solids to liquids, right? Sorry, your liquids to gases. So vaporization is a process of conversion of your liquids to gases. So the heat which is involved in changing 1 kilogram of your substance, your liquid, into your gaseous form is known as your heat, a latent heat of vaporization, and that heat is in joules. So the unit would be joules per kg. Moving on to your fusion, we all know that fusion involves melt. We all know that fusion and melting are the same thing. So that is basically a process of conversion of your solids to your liquid form. So here also, how can we explain water vapor present in atmosphere? Sure, Ashish, we'll discuss that in the practical based question. Just hold on for a while. So latent heat of fusion would be definitely given by the definition as your the amount of heat required for converting of 1 kg of your solid into your liquid form in joules. The amount of heat in joules which is required for the conversion of 1 kg of solid into liquid state. So this is the definition of a latent heat of vaporization and latent heat of fusion. Now the next question is, why do we see water droplets on the outer surface of glass containing cold water? I hope, Ashish, this will give you the answer. We all know that if we are having a cold water in the glass, then the temperature is low. Nearby in the surroundings, we all know that water vapors are present. As soon as the water vapors will come in contact with this cold temperature, they will start getting converted into your water droplets. So they get deposited basically on the surface of your water glass. And this also explains that the presence of water vapors in the atmosphere. And this is basically the reason why we see water droplets on the outer surface of a glass containing cold water. Now, the next question is, why does water kept in earthen pot remain cool? We all know that the earthen pot, which is available to us, has pores on the surface, isn't it? So due to that, what happens is, we all know the particles, which are particles of water, which are present, they have different energies. So the particles which have more energy, which have more kinetic energy, they can escape out through these pores, and the leaving particles, they have less energy. And since the escaping of the particles which are having more energy requires latent heat of your vaporization, so that heat is provided by the rest of the particles. As a result, the remaining particles of water, they have low temperature, and the water kept in the earthen pot becomes cool. Exactly. Correct, Raja. Moving on to your practical based question. So the question is, mention two precautions to determine the boiling point of water in your laboratory. Shivam, basically, we were saying that the earthen pot, it has your pores on the surface, and as a result, many of the particles which have more kinetic energy compared to the rest of the particles, they can escape out through these pores. While doing so, they take the energy from the rest of the particles which are there in them. So the rest particles, they get lower, and the energy of them is lowered, and as a result, what happens is the temperature of them decreases and the water kept in the earthen pot becomes cool. Moving on to the next thing, your practical based question, mention the two precautions to determine the boiling point of water in your laboratory. So one of the precaution would be that stir the water continuously. Why we should do this? So we should stir the water continuously so as the temperature remains constant. And the next point would be, do not forget. Sure, Nimisha, let me complete this question. I'll move back to the second question again. And the second point would be, do not forget to add pumic stones. Why is it so? We all know when we used to boil water, then there is bumping of water taking place. And by adding the pumic stones, we all know there are pores in these pumic stones and they provide a space for the air. As a result, it reduces the bumping taking place while boiling the water. So these would be the true precautions which you can mention in your exam if this question comes. The precautions for determining the boiling point of water in your laboratory. Okay, moving back to the second question, which was asked by a doubt by Nimisha. Why do we see water droplets on the outer surface of glass containing water? See, we all know that if we put cold water in the glass, then what will happen? They are having low temperature. The water vapors which are there in the atmosphere, they are having high temperature. As soon as they come near to the surface of the glass, then what happens? What happens? The temperature is lowered. As a result, the change of state takes place from the gaseous to your liquid, and they get deposited on the surface of your glass. Moving on to the next thing, that are your important points to remember. So guys, while preparing for this chapter, you should take care of few things. Let's see what are there. Remember the names of various processes occurring during change in states of matter. So while you're writing down the processes, do make sure that you're writing the correct change of states for those processes. The next is also revise the effect of pressure and temperature during the changes of state. Shubham, I just explained that pumic stones, they have pores in them, and that is why they provide space for the air, and it does not cause bumping that much. Also revise the effect of pressure and temperature during the change of state. What happens to the heat when vapors condense? Aditya, which heat are you talking about? There would be obviously the transfer of heat taking place. So also do take care of your effect of pressure and temperature during the change of state. How the pressure and temperature are playing an important role while the change of state. Revise the factors affecting evaporation. That means your humidity, surface area, temperature, and wind speed. You can be asked question about them in your exams. So do revise them completely. And the last point is, don't forget the cooling effects of your evaporation, which this is one of the most important topic of your from your exam point of view, from which there are a lot of reasoning questions. Obviously, Cosmos, acetone will evaporate faster than water. Aditi, you want me to explain the latent heat again? So, yeah, the latent heat, let's quickly have a review of it. Latent heat is your hidden heat, which is basically responsible for change in state. And it does not increases the temperature while the change of state is taking place. So if we are talking about the latent heat of vaporization, we all know what is vaporization. We all know what is vaporization. Vaporization is a process of conversion of your liquid form to your gaseous form. So when 1 kg of your liquid is getting converted into your gaseous form, at that point of time, the amount of heat energy required for this conversion in joules is known as your latent heat. I hope it's clear now. And similarly, we have your latent heat of your fusion. Okay, Nina, do you have a doubt? What about the effects of temperature? See, if we increase the temperature, then definitely the evaporation or the rate of the process will increase. If we decrease the temperature, then the particles will have lower energy. As a result, they'll come closer to each other, and as it will cause what? Change in the state. Fine. I hope you all are clear with all your concepts. And to know how Merit Nation can boost up your preparation for science with Power Pack Premium courses, go to this link, which is and send us your details. And this URL is also available in the description below. And if you want more such sessions of the different chapters, then please like the video and subscribe the channel. So I hope that was all about your matter in our surroundings. With this, we'll be ending the session. I hope it was informative and you all enjoyed the session. Thanks a lot. Bye, everyone.